for the presentation. I'll leave the floor to you.
Thank you very much. Well, thanks for choosing my session. First of all, my name is, I pronounce it Andrzej Grzesik, but I understand that you might find it funny. The project I'm going to talk about is called AirCasting. The motto for the project is share your air, but we'll come back to that. Those are my contact details. If you want to tweet or give me any feedback, I'll be happy to listen to that, to read it, or to have it personally. A few facts about me. You don't probably want to hear about my life. You can see the pictures. I believe they are enough. And two things. I sometimes say I hate computers, so don't worry if I say so. And if you have any questions, just raise your hand, wave, shout. I'll be happy to take a break and ask them while they appear. I also have a tendency to start speaking faster and faster, so if I do that, just wave your hand, I'll slow down. So, there is this thing called the environment. We all live in it, and basically there is this fact that we emit a lot. This is a picture from Krakow. In the distance you can see a hotel, and that's not fog, unfortunately. In Krakow we sometimes have problems with smoke, and this hotel should be, well, slightly blurry and behind white something, and that's because sometimes when the wind doesn't blow and people start using coal furnaces, they emit a lot of smoke, which sometimes just sits in the air, and sometimes we break the norms, sometimes a few times, not too often, but again, air in Krakow is not perfect. So if you know something is bad and you want to improve it, well, there is a simple rule. Just first you have to measure it, to know where you are, to know where you want to go, to know when you're there, and if you're going in the right direction. So there is a project called, well, AirCasting, which consists of, well, the central element is the AirCasting app. This is an Android app that you install on your phone, to which app you can connect multiple sensors, like this one, or like sensors I have not seen because some guys in Singapore or Hong Kong or in the US have constructed themselves. They are usually Arduino-based, but some people have also created some more complex constructions. You can also connect a heart rate monitor, you can connect a pulse oximeter. We are in the process of attaching one to the application. You can also add some cool indicators like a vest or a t-shirt with LEDs or a baseball cap with LEDs. And then you can upload the data to either your server for your own personal storage, or if you want to share it with everybody, you can upload it to AirCasting.org. And then other people can browse your data, browse other people's data, see how things change, how the air is in your neighborhood. Once you upload that, you can see how my surroundings, my environment affects me. And if you go to the website, you can see how your area looks, what it looks like. Of course, there's this problem that some people, well, if people record, then the data is there. If nobody records data in a particular area, then we won't have it up there. But that's not yet a problem, because right now we are building a platform for sharing and recording. Later, we will worry about marketing. So, to record and connect, it's actually quite easy. You just launch the application, which is available on Google Play, connect a sensor, well, like this one, or you can get, for example, a Zephyr heart rate monitor, attach it by Bluetooth, and it should work. That's the theory, because this project it's a normal hardware hacking project, so things will break, things will be broken. They are not always entirely stable. We are doing our best to make it more stable, but also we are doing our best to connect more and more sensors. When you connect and record, then you can go online and actually see what's happening. You can review your sessions. So when you're recording, when you press record, you start a new session, and then when you say stop, you can decide whether you want to upload it online, and then everybody can see it. Or, well, you can also do that to your own server. There is nobody's forcing you to put anything to the public one, but the web interface available at aircasting.org allows you to check different measurements for sensors, see, compare things. It also uses Google Maps to display the geographical data because all Android phones provide some location support. And okay, but how do you actually measure it? As I told you, there is the Android app, and there are sensors. I have a sensor like this with me. I can show it running probably after the session because it will be hard for all of you to notice how it works because of the distance. But it consists of a CO, so carbon monoxide monitor, humidity monitor. It can monitor temperature, and it talks to your phone by Bluetooth, or it can talk to your computer by USB. It's a normal Arduino-based device. Well, there is a lot of cables underneath. It's not that pretty, but basically that's how it's done. So you can do it at home. It will take probably 4 hours and $100 to get the elements. The instructions are also available online. Some other sensors that we have look like that, and those are actual devices that are already connected to the tool. And well, there is also I mentioned LEDs, because recording is one thing, but it's also good if you can share the information that you record with other people to create indicators to actually show that either it's being loud or the air has went worse. It's probably a useful thing for some city municipalities so that they can make automated information systems with that. This is an I/O board with an LED strip attached. It's a very simple prototype just to make sure the software connectivity works. If you're a more engaged person and live in New York, you can go out in a vest with LEDs. And this is an actual thing. I know the guy, his name is Michael Heimbinder. He's actually the originator of the project. He's really passionate about the environment. He lives in New York, and he's the driving force of AirCasting. He created such a vest so that he can wander around the streets, show whether the sound levels are exceeded or whether certain gas levels are exceeded. Well, the unfortunate thing is that the vest doesn't say what actually it is tracking, but well, if you attach a label and make a stationary display, if you just use the I/O board and attach lots of LEDs, the software is already there. It's probably another few hours of work, and you can attach it to your home or shop or somewhere in the street. And of course, the website shows corresponding data. And because it's a website, it's using JavaScript. It's also sharing the data openly, so there is an API for getting the data. Because part of the rationale for creating AirCasting was to actually enable monitoring and enable data gathering. For governments and environmental organizations, it's a big problem because they would need to create and deploy thousands of sensors, or maybe even more. Create connectivity, gather the data, fix them, check them, do everything. If you can crowdsource that, then probably the makers and hackers communities will be more than happy to first play with the designs, tweak their phones, code some applications, then actually where they go, they will measure. So almost for free, they would get data about the most popular areas. Of course, most popular is for those people because it's hard to imagine people in some remote village to actually building things with electronics because they have sometimes other problems. But I was surprised to find somebody in rural China actually to play with that and uploading data. So the information, because the platform is available, they are already using that. And what's inside? Well, first of all, the backend or the website uses Rails and AngularJS. That's pretty normal setup. I have all the best words about Angular. It helped us a lot. Previously, we were using Backbone, but it turned out it wasn't so good. And Androids, the clients. Basically, Android and Bluetooth. The best feature of maker community and the people who actually use those hacked devices is that they acknowledge that they are hacked. So they acknowledge that the UI might be ugly and unintuitive, and sometimes things just break. Sometimes your phone, well, it's not that we can break the phone because Android as a framework prevents that, but sometimes your battery might be depleted or some other bad things might happen. because yes, this platform, especially the Android client, has some hiccups. They are being worked on, but it's an open source project, not my primary occupation right now, so sometimes certain things have to wait. Of course, it's available on GitHub, so if you play with it and find something, you can submit an issue. I'll be more than happy to at least look at it. I mentioned Bluetooth. Bluetooth is our connection method of choice for the devices because it doesn't have cables, so you can just put the sensor on your backpack, put your phone in your pocket, and basically you should be happy. Well, this is how you connect to Bluetooth in Android, officially. And if you go to Stack Overflow, you actually stop using the official API and use reflection, because the official API is not really it works, but it allows only to connect one device, and if you use the unofficial way, you can connect a few devices. But there are still tricks. Some devices only like to be connected after certain other devices because the order sometimes matters, which is not what you would expect, but then you have it. Also, playing with byte arrays in Java and Bluetooth sometimes gives you unexpected results. This is basically a bit of a pain, but I cannot do much about it. And yeah, I'm still dreaming of a device that could survive a whole tech conference running on 3G connection and allowing me to browse internet. If you add GPS connection and multiple Bluetooth connections running at the same time, we are talking 8 or 9 hours of operation if you're lucky for the phone. And of course, you have to carry batteries or some other power providers for your sensors because some just don't have their own batteries. Usually the packaged heart rate monitors that you can get have their own batteries, and they are pretty good. But, well, again, for a thing like that, the best way to power it is actually from a MacBook with a USB cable. It just gives the most juice and the most runtime. Another problem with Android is speed. I have to learn a lot. I learned a lot, but there's still really a lot to do because supporting multiple Bluetooth connections requires a different approach than supporting just one because of amount of threads that are running and because of the database. Android has SQLite, and SQLite is quite good. It allows multi-threaded access as long as the number of threads is 1. If you have a 2-hour-long session from 5 sensors, collecting data points roughly every second, you get 36 data points. I tried to record that and save that into the database on an HTC Desire, and it took me 17 seconds. And that was after improving the performance of the query. That's a bit sad, so that makes the database another, well, tricky place to work. Because, well, when you're executing a query, you cannot do anything else because it's only one thread can access it at a time. The solution is easy, just split inserts, split all queries, but it complicates the code. And I've had a bug that I really wanted to show, but unfortunately Android fixed itself and stopped working with the bug. It was, well, pretty peculiar, but luckily Android moved forward and it doesn't execute both the if and else branch of a particular bit of code. Konrad has seen it, and it was a bizarre, and you can see Konrad there. You can ask him about the details, or I'll be happy to talk. And yeah, if you have any questions, I'll be happy to answer them. But I don't see anybody waving. Can you raise your hands?
Questions? Yeah.
When you upload the data,
Yeah.
after your session is done, can you partition it so that some measurements go to the public domain and some go to your private?
There was no need like that yet. You can delete, if you're recording several sensors at once and you would like to delete certain sensors, you could delete your sensors and then upload what stays on your phone, but other way it's not possible yet. If there is a need for such a feature, it's possible, of course, but
No, I was thinking you might want to share the environmental data, but maybe not your health data.
yeah, that makes sense. It's using a, well, pretty simple REST API, so that would be, you could always upload the whole thing and then delete your heart rate. That would work right now.
Further questions?
So guys, if you're into environment, you would like to check something, just I encourage you to download the application, play with it. If it crashes, just please submit a bug report. I'd appreciate some feedback, please. And well, these are the resources. It's all on GitHub. The code is public, both for the server and the Android. Also, the designs are publicly available. So if you're into hacking, you can still construct something like that. The list of parts and the construction process is all detailed online. Thank you very much.